Okay, if I was going to teach you how to do a study sheet, this would be some rambling thoughts about what I would put on it. First of all, in the upper right-hand corner, I would put my name, and I would put down which chapters you were summarizing on this sheet and the date of the test. This is going to be a study sheet for chapters 3, 4, and 5, and the date of the test is whatever the date of the test is, 5th, 6th, something, Thursday, whatever the date for Thursday is, October the something. 8th, I guess. I do better math. Okay, and then I know. It's for test chapters 3, 4, and 5. Okay. Now, again, for the love of God, don't make this pretty for me. Don't spend hours making this something you want me to. I'm not marking the quality of this. I'm marking what's on it. If it's messy, it's messy. I mean, to your benefit, of course, should be neat, but that's your choice. You should be using, you can use lined or unlined paper. You can use highlighters. You can use colored pens, pencils, write as small as you want, as big as you want. Type it. I don't care. But don't spend time making it look pretty. It's about summarizing everything that's important in these 3 chapters. Even if you think you know it, make a note of some of the things that are very, very important, because at Christmas time, when you have all kinds of things on your mind and you want to go back and you want this study sheet to be a complete review of these 3 chapters, that if it was desperate, you've never had to go back. Look at your notebooks at all. These 3 chapters should be summarized in this one piece of paper double-sided. Think about that. Even if you know it now, will you know it at Christmas? Okay? So I would start off by putting a little something down about your 3 states, your solids, liquids, and your gases. So maybe you even want to do something like this. This is just a suggestion. Okay? Maybe have a little picture of each. And you should know that remember, you're going to compare volumes and you're going to compare shape. So if you want to talk about definite shape, maybe a picture works better for you. Definite shape, definite volume. Some people are word people, some people are picture people. So if you have a container, all of your atoms touch, and they're very, very organized. Look in your textbook for a good example of the picture. A liquid has indefinite shape, right? But it has a definite volume. So it can change. So in a container, the molecules touch, but they're not organized. They're kind of more random. Again, that's not a good picture, but your textbook, your booklet has a nice one. And for a gas, it has indefinite shape and indefinite volume. So if you can think about that in terms of compressibility, these ones here are separate and not touching at all. This you can compress because the particles are not touching, and you can't compress a liquid or a solid. If I was going to summarize things nicely too, for a little bit later on, I would do something like this. Remember your solid, your liquid, and your gas. And what happens here, at that stage when it changes from solid to liquid, that's called either your melting point, or going backwards, your freezing point. When it goes from a liquid to a gas, that's your boiling point. Or in reverse, that's your condensation point. That's helpful for that stuff. You should have on your study sheet somewhere the table that shows how matter is subdivided. So matter can either be a pure substance, or matter can be a mixture. If you're looking at pure substances, what are they? Mixtures, what are those? And get specific. So you have your homogeneous mixture, your heterogeneous mixture. You have your elements and your compounds. You should list some properties of each. Compounds have 2 or more elements, right? That kind of thing. 2 or more elements. The elements themselves, of course, are the simplest form of matter in the periodic table. Think about homogeneous versus heterogeneous. Homogeneous is the same throughout, hetero or not. And all the little things. A couple of examples would go nicely there. After we did that, we did a lot of work on physical changes and physical properties. I'd have some examples of each so that you understand the differences of those. physical properties, physical changes. Maybe something as simple as this. H2O as a solid going into H2O as a liquid. The identity of the substance does not change, only a change in state. Compare that to chemical changes, the changes that are chemical, and chemical properties. There's lots of keywords that we learned when we're doing that, and they would be a good spot to get those summarized on here. So that things like decompose and rust and corrode and burn, all those words that imply very much a change, versus physical things like break and cut and bend. And the words like malleable and ductile, things that you might not necessarily remember right now, but you refresh on this sheet, it will help your brain to lock them in. All those kinds of keywords, be able to do some examples. There's going to be quite a few questions on that on there, so make sure that's in your head. I'd probably have a little staircase on my study sheet, and I'd have the word metal over here, and I'd have non-metal over here, and maybe some properties of each. Conduct, doesn't conduct, things like the fact that it has a high melting point, low melting point, all that kind of stuff. I would have a note somewhere on my study sheet about the Hofbrinkels. It's very important that you understand which elements are diatomics and what that means. I'm looking for that. We did a little section on energy. There should be some notes, or at least just a quick ditty, a half of a, not definitions, of course, but some explanation of endothermic versus exothermic. You need to have that straight in your mind. Exothermic reactions are those that release heat, so the burning of a piece of wood. Endothermic reactions are those that absorb heat. So they're going to absorb heat into a reaction. It's going to take heat in. Okay, it's going to be cold. Exo is going to be hot. We talked a little bit about signs of chemical changes. Those are really important to help you decide if it's chemical or physical. That's probably would have been better up with the other stuff. But that should be on there, signs of chemical changes. So things like a new color, a new smell, a change in heat, a new substance being formed that wasn't there before, like gas bubbles or precipitate, some kind of insoluble solid that wasn't there. In terms of the exothermic and the endothermic, we mentioned a little bit about changing energy forms from one to another. There was a note in there about comparing a solid, a liquid, or a gas to high energy, low energy. So a solid has low kinetic energy, but a gas has high kinetic energy. Think about, I'm going to abbreviate KE for kinetic energy. Think what the burn you would get from a steam burn versus a hot water burn, because it has much more kinetic energy. So exo, endo. I'm looking for an indication on your sheet that you have given some thought to that. We kind of jumped in after that in chapter 4, and we started talking about the names of the groups on the periodic table. So your names of your groups. So I would probably, if they're not in your study sheet, that means, I don't know, I would think you won't get a perfect mark in your study sheet if you don't have some kind of indication that you gave some thought to the periodic table summaries. So this group has a name, the noble gases, that group is the halogens. You don't have to be very specific, but you can get the idea. Group 1 are the alkali metals, group 2 are the alkaline earth metals, the section in the middle. The B group, those are the transitions. I'd have a note at the bottom. These are the inner transition elements at the bottom. And they, of course, are in between the S level and the D level when you're filling. Periodic table stuff we also discussed were the first three birds of the periodic table, or the atom theory rather. So we had Dalton, Then we had our plum pudding negatives in the positive sphere. Then we had Rutherford with his small dense nucleus. And then after that, of course, if you want to put group 5 stuff with group chapter 5 with chapter 4, that's fine. After Rutherford came Bohr with his planetary model, with the nuclear model for Rutherford. Then we had after that quantum mechanical model, which is our nucleus surrounded by electrons in regions of high probability. And you get the very non-distinct picture for the quantum mechanical model, kind of that haze or that blur that comes with a fan whizzing around. And that was your quantum mechanical model. Electrons exist in orbitals. And this is Bohr. So something like that would show me that you knew what each person's theory was and what the picture looked like. We also did the electron-proton numbers in an atom. I would give an example, say, of something like, I'll just pick a random one. I'll make one up. Let's just say we're talking about a copper. Let's just say we said copper 65. You should have an indication that's a mass number. Chemical symbols should be on there for an example. 65 for the mass, and the atomic number 29. Nuclear symbol I'd list beside that. 29 protons, 29 electrons, 36 neutrons. Make a note that those particles, the P and the N, so to speak, go inside your nucleus, and everything else is outside the nucleus. Everything else being the electrons. Electrons are out here, kind of spinning around, depending on whose model it is. If that's a nuclear symbol, you should understand about the isotope. So if I do another one beside it, and I had Cu64, the atomic number is going to be exactly the same, but you're now going to have 35 neutrons. So you should have an understanding about isotopes versus isobars. I'd have that on there too, if I were you. Difference between isotopes and isobars. I've just drawn two isotopes right here, two isotopes of copper. Isobars are two elements of the same mass, but different atomic characteristics, different identity altogether. Chapter 4 was fairly short. We did that, and then we also talked about, for example, on your periodic table, it lists the average atomic mass of copper to be 63.546. Why is that number not a whole number? That's because that's an average of all known isotopes of copper on the planet. And they're all blended together. So by looking at that, most isotopes are probably 63 or 64, in the range of 65. In chapter 5, we start off with the Bohr diagrams and the configurations in the quantum mechanical model. So you should have a picture. I'd have at least one Bohr diagram. I'd have, like, say, sodium on my sheet, 11 protons in the nucleus, 2 electrons in the first, 8 in the second, and 1 in the third. Somewhere on your study sheet, I'm looking for an indication that you know the valence number of electrons for each group. At the top of your little structure, your little pretend periodic table may have like a 1 in group 1 and a 2 in group 2. Total number of valence electrons. I want an indication that you've got that as your valence. Somewhere on your study sheet, I'm going to want to see that you have understood that the number of valence is what changes when it becomes an ion. So there better be something on there about ions being a gain or a loss, the nearest noble gas. The octet rule is what everything is striving to become like. Octet rule with your 8 electrons. And there should be something on there for sure about the filling order. So you should know you've got 1s2 and your 2s2 and so on. Maybe you're going to want to make a note that the only things that don't match your table, maybe a special note about the fact that the 3D sublevel and the 4F sublevel are the two locations in the periodic table where those values don't exactly match the period numbers for those elements that they're in. Should be something on there about what the word anion and cation means. Anions and cations. Should be something on there about the ending changes for the anions, that it becomes an IDE. Maybe something with the keyword about isoelectronic, what that means and how elements are trying to gain or lose electrons to become like the nearest noble gas. Might want to make note of the fact that for certain elements, they're not going to actually end up with an octet. They're going to end up with a duet, and which elements those are, and why a duet is still happy. Of course, that's because if the nearest noble gas is helium, then it's going to have to gain and lose to become like helium. Don't forget about the names of the isotopes of hydrogen. Kind of flashing back to something I just remembered. The hydrogen isotope names, there's 3 special names for those. And that hydrogen as an ion can become a 1+, meaning it lost 1 electron and went back and actually has no electrons at all. Or it could become a hydride, where it gained 1 electron. Those are the main thoughts that I can think of for now. If you'd like me to have a look at your study sheet before the test and you have it done, I'd be happy to do that for you. If you follow these simple rules and go through your binder and jot down a bunch of facts, you should be perfectly fine. Remember that when you're studying this study sheet, during the test, I guarantee you're going to close your eyes and say, oh, I remember that. I wrote that down on my study sheet in the far right-hand corner. What did I write right there? The fact that you write it on your study sheet and you study it from your study sheet will help you to commit it to memory. The study sheet must be submitted before the test starts on the day of the test. You do not get to use it during the test, but you will at the end of the semester. Take your 3 study sheets, shrink them down into 1 study sheet, double-sided, that you can use during the exam for the whole exam at Christmas time. Good luck with your study sheet. Thank you.